Multiverse. The multiverse theory is one of the most fascinating and controversial ideas in modern science. It suggests that the universe we live in may not be the only one in existence. Instead, there could be countless other universes, each with its own laws of physics, dimensions, and histories. While the concept has become popular through science fiction films and television shows, it also has roots in serious scientific research and philosophical discussion. Although there is currently no direct evidence proving that the multiverse exists, several scientific theories predict the possibility of multiple universes. The multiverse theory challenges our understanding of reality and raises profound questions about the nature of space, time, and existence itself. The idea of multiple worlds is not entirely new. Ancient philosophers, including the Greek philosopher Democritus, speculated that countless worlds might exist beyond our own. However, the modern multiverse theory began to develop through advances in physics, particularly during the 20th century. Scientists studying quantum mechanics, cosmology, and string theory discovered mathematical models that naturally led to the possibility of many universes rather than just one. Although these theories were developed to explain different scientific problems, they all arrived at a similar conclusion: our universe may simply be one part of a much larger cosmic structure. One of the most well-known versions of the multiverse comes from the theory of cosmic inflation. According to the Big Bang theory, the universe began approximately 13.8 billion years ago from an extremely hot and dense state. Shortly after the Big Bang, scientists believe the universe experienced an incredibly rapid expansion known as inflation. Some physicists suggest that inflation did not stop everywhere at the same time. Instead, certain regions continued expanding while others formed separate bubble universes. Each bubble would become its own universe with different physical properties and possibly different fundamental constants. Our universe would simply be one bubble among an enormous number of others spread across an infinitely expanding space. Another important interpretation comes from quantum mechanics, particularly the many-worlds interpretation proposed by physicist Hugh Everett III in 1957. Quantum mechanics describes how particles behave at extremely small scales, where events often appear random and unpredictable. According to the many-worlds interpretation, every quantum event creates multiple outcomes that all occur simultaneously, but each outcome exists in a separate universe. For example, if a particle has two possible states, the universe effectively splits into two branches, with each branch representing one outcome. This means that countless versions of reality could exist, with every possible decision or event creating new branches of the multiverse. While this interpretation solves certain mathematical problems in quantum mechanics, it remains highly debated because these alternate universes cannot currently be observed. String theory provides another possible explanation for the multiverse. String theory attempts to unite quantum mechanics and general relativity into a single theory of everything. Instead of treating particles as tiny points, string theory suggests they are actually vibrating strings of energy. These strings can vibrate in different ways, producing different particles and forces. The mathematics of string theory allows for an enormous number of possible configurations of the universe, often referred to as the string landscape. Each configuration could produce a universe with different laws of physics, different numbers of dimensions, and different physical constants. Some scientists estimate that there could be as many as 10 to the power of 500 possible universes predicted by string theory. Scientists have also classified different types of multiverse. Cosmologist Max Tegmark proposed 4 levels of multiverse theory. Level 1 suggests that space is infinite, meaning regions far beyond our observable universe could contain other areas with conditions similar to ours. Level 2 describes bubble universes formed through eternal inflation, each possessing different physical constants. Level 3 corresponds to the many-worlds interpretation of quantum mechanics, where every quantum possibility exists in a separate branch of reality. Level 4 proposes the most extreme possibility: every mathematically possible universe exists somewhere, regardless of how different its physical laws may be. Each level expands the idea of reality beyond what humans can directly observe. The multiverse theory has significant philosophical implications. One major question concerns the uniqueness of humanity. If infinitely many universes exist, there may be countless versions of Earth, the solar system, and even individual people. Some universes might be nearly identical to ours, while others could differ dramatically. In some realities, history may have unfolded differently, resulting in completely different civilizations, or even no life at all. This possibility raises questions about free will, identity, and personal choice. If every possible decision creates another universe, then every version of ourselves may exist somewhere in the multiverse. Another philosophical concept connected to the multiverse is the anthropic principle. Scientists have observed that the physical constants of our universe appear to be finely tuned to allow the existence of stars, planets, and life. Even tiny changes in these constants might make life impossible. The anthropic principle suggests that we observe such favorable conditions simply because only universes capable of supporting observers can be noticed. In a multiverse containing countless universes with different properties, it is not surprising that at least one would possess the conditions necessary for intelligent life. Despite its appeal, the multiverse theory faces significant criticism. One major challenge is the lack of direct experimental evidence. Since other universes may be completely separate from our own, scientists currently have no reliable way to observe or measure them. Many researchers argue that a scientific theory should make testable predictions, and some versions of the multiverse are difficult or impossible to verify. Critics also warn that relying on unobservable universes may move science away from empirical evidence and into speculation. Because of this, some physicists question whether the multiverse should be considered science or philosophy. Supporters respond that many accepted scientific theories originally lacked direct evidence. For example, black holes, gravitational waves, and the Higgs boson were predicted mathematically decades before technology advanced enough to detect them. Similarly, future discoveries in cosmology or particle physics may provide indirect evidence supporting the existence of other universes. Some researchers have suggested that collisions between bubble universes might leave detectable patterns in the cosmic microwave background radiation, although no conclusive evidence has yet been found. The multiverse has also captured the public imagination through literature, films, comics, and television. Stories involving alternate realities, parallel worlds, and different versions of familiar characters allow audiences to explore what-if scenarios that reflect the scientific ideas behind the theory. While these fictional portrayals often simplify or exaggerate the science, they have increased public interest in cosmology and encourage discussions about the limits of human knowledge. In conclusion, the multiverse theory is one of the most ambitious and thought-provoking ideas in modern science. It proposes that our universe may be only one of countless universes, each potentially governed by different physical laws and histories. Supported by concepts from cosmic inflation, quantum mechanics, and string theory, the multiverse offers possible explanations for some of the deepest mysteries in physics. However, it remains a hypothesis because no direct evidence has yet confirmed its existence. Whether future discoveries ultimately support or disprove the multiverse, the theory continues to inspire scientific research and philosophical debate. By challenging our assumptions about reality, it reminds us that the universe, or perhaps the multiverse, may be far more vast and complex than we can currently imagine.